And I like the idea of just using string names and for stuff for animations and not having this big ridiculous list, just because it would be better if like Unreal actually worked nicely with slotting stuff into the data structure, but it's too much. It's too much work to actually organize all that crap. And then like if you change something, then it's just broken. Alright, so what were we doing again after all this shenaniganry that we had to go write out in C++? Right, we were just trying to change the speed of an animation, and then somehow we got sidetracked in order to do all that. Alright, so really what we were doing is we want to call the math percent inverse between floats, and the velocity magnitude here is just like this. You can make spaghetti too? Oh no. Just all this all this stuff. Oh, literally just that little section right there is like all this garbage. Yeah, that's so maybe Adam will have an easier time with all the blueprint crap because he's used to dealing with Harmony, and it's just absolutely insane display render node system. So he'll be like, "Oh yeah, you know, like yeah, this is just perfect sense," and I'll be the one going like, "What the fuck?" All right, percent inverse between floats, and then we're going to we'll be able to call get animation data. We want to get the animation duration. Alright, so we want to actually multiply this animation duration. It's going to go from what? 0 to 1 negated, so it's going to go from 1 to 0. 1 to 0. So it's actually going to get slower as it goes in there. I actually want to go from 0 to 1. So it's not percent inverse between floats, it's percent between floats. And then we just want to multiply that. So it's going to be this, and we're going to multiply it, and then I guess we're going to multiply it by 0.5. and then we just add those two values together. Get animation duration. That's not necessarily what we want. I guess it's just get duration. Yes, that looks a lot prettier than we had before. And I guess we could add like a variable here for like default animation or something. Get velocity magnitude. Alright, well let's go ahead and see if this works. Can I walk? Can I actually walk slow enough with the controller? Alright, so I'm breakpointing this just to see what this value is. So it's the current value is 655. The minimum is variable not in scope. Damn. It's from 0 to 1, so it's starting at this default duration. Let's see, step into the return value is 1.06. This duration is going to be 1.045. We're increasing the duration, so we don't actually want to increase the duration. We want to decrease the duration. Yeah, because the duration is in seconds. What am I doing? So what we want is we want to subtract. Or we can multiply it straight off, but why don't we just subtract? It's like we're basically going to go from half speed to full speed. Yeah, like that. That looks so much better. Looks like he's got some sort of swagger going on. Alright. So we got that going, and I guess what I want to do is I probably want to make a function or something like that, which is like determine get duration or something. So we'll just go ahead and do that. Let's do a get duration. I guess, yeah. Get anim duration. And what we're going to do is basically take all of this stuff right here and chunk it over into this get anim duration function. And why don't we add an input here, which is the animation name, maybe? And then we need outputs. So we need this thing, which is going to not be a string but a float. Like so. So all we have to do is call get anim duration, just like right here. Pass in our animation, chuck that right in there, and then we can just get rid of all of this. And then I'm fine with copy pasting that. So it's basically like as soon as you are in this state, start playing it, and then this will just update it every frame with the duration calculation stuff. Now the question is, do I have the duration calculation for stuff being close enough? So let's see. Play with duration and loop. Alright, play direct. Let's see, it's inside of this one. So we're setting our wanted state. Alright, yeah, it is basically equal. Alright, so what we're going to want to do here is I'm going to want to save this stuff real quick. Exit. And we're going to change this method to basically just, we're going to need it to make sure that it's, because we're comparing floats here. If the floats are like really close to each other, we don't care. So we're going to do if fmath absolute value of m duration minus anim state dot m duration is less than the tiny float variable. So let's just go grab that. It's in global. It's less than tiny float, then return false. Let's see, is greater than tiny float. That's what we need to do. So it'll set some variables and do all this crazy stuff, but it'll figure out at the end of the frame if nothing needs to change. So yeah, we're just telling it to play the animation every frame, and it's basically just queuing it up and being like, well, was I already playing this animation? Was it already playing at the speed we wanted? Yeah, okay, don't do anything. And we're just setting class variables, so it's not really, there is no real expense to it. So it won't do anything. Alright, so everything works as we want it to. Not bad, alright. So we've got our blueprint set up here, so what we can do is there any reason we can't just make like a macro and pass in some more stuff? I don't really want to over-engineer it though. Yeah, the only thing I'm looking at is there's a lot of like walk idle pasted around here. That's okay, it means we can change stuff up. So I'm trying to think if there's something else that I want to do here besides just go replicate this work inside of the other classes. Like, I think basically we just want copy pasted logic for a lot of this, because it's going to be on a per character basis, and like once you get a character working, like you just leave it alone and build the other character. I think that's probably fine. Like, I don't see any other. There's kind of a limit for how much I want to shove into the same spot in code, and like you can make like a whole bunch of code, and then you can also like condense it. And the idea is, when you balance that out, at some point here, we're just going to be writing one-off code for literally everything. Where does that start? If it starts with this animation control stuff, then it means if we wanted some other character to use the same, like, going between different running states, we would have to basically copy-paste this, and then if we wanted to change how everything worked, we'd have to replicate it all over. Which might actually be just fine to do, so maybe I should just get over and start copy pasting stuff. Just be fine with it. I don't want to copy paste this thing though. Do I? Can I actually copy this whole function? Maybe. Let's find out. Well, I could actually just make a parent class for these things real quick, which will be like bitey movement state right in here. And what I can do is I can yeah, I probably should. And I should initialize and all that, call a few things. Like we're going to want this bitey movement controller thing, so we should have the bitey state base should be the thing that we got here. So let's just make it happen. So the bitey state base should have an initialize event. So we need a parent. Variable should be called parent, and it should be a bitey movement controller reference. Cast a bitey movement controller. Alright, that's fine. And then we want a function, we want it called getAnim duration. Pass it right in there. And we need the animation name, so we need inputs. Let's see if I can actually paste this. I cannot. So we could just pass the animation name in there like that and have it work. So the base state is going to have this. So we're going to have a comment here for initialization. Alright, compile that, save it. And what we want to do is we want to make this walk state a child of this thing. So if we do class settings, this should be byte state base. And then basically we don't need this get anim duration. We can just get this and delete that. Alright, and it actually replaced stuff nicely for us. Need state machines, bro? Yeah, thanks. Thanks, Kento. Just trying to figure all this stuff out. So if we derive from the byte state, we have this, and we also have the anim duration function, which is properly set up, and we can override that. So the question is, I don't know how these events work with the initialize. So initialize for walk state, and then I also want this initialize for base byte state. So let's see which order these things actually get called in. So let's F9 that and F9 this. And let's hit play. Alright, so the initialize gets called inside of the walk state and does not get called inside of the other state. So it overrides the initialize event. So how do we call the initialize event on the parent? So let's see if we can do that. So let's see, there should be able to. If you want to call an event on the parent, for example, begin play, add the same event to your child's event graph, then right click the node and select add call to parent function. Alright, so add call to parent function. Oh, okay, that's pretty neat. So let's compile that out, save and all that, and let's make sure it actually happens. Alright, so the walk state gets called, then the parent state gets called. Alright, cool. So that totally works. Alright, so that was definitely not as difficult as I thought it would be to just nicely deal with that stuff. So, what do we want to do? We want to have the same animation stuff going. Well, how in the hell is this anim duration actually working? It's target walk speed? Like, I guess we need local variables here. We need maybe we should pass in the two things? Or should we have our two different speed differentials? Yeah, why don't we just have our two speed differentials be as part of the class? This will be minimum speed and maximum speed. So we get two floats. So inside of the initialize, we are going to actually call set on these things. So let's see. We need to delete parent 0. So let's call set What are these? Are these category default local variables? No, these are not local variables. Whoops. We want variables here, so 2 of those. So minimum speed and maximum speed. Alright. Learning a lot of stuff about how to actually use blueprints at the moment, which is good. Alright, so walk state, we have some variables, but what are these? So these are variables not be editable on an instance of this blueprint. Blueprint read only, expose on spawn, private. So we should be able to do, like, I don't like that I can't see the variable. Over on the left here, so I can't like just nicely drag it out onto here. Alright, so we want that. And you can hook these things back into each other? Oh wow, that's awful. So it's gonna be get walk speed. Get trot speed. Alright, so that's looking pretty decent. So all I have to do is set the same variables up on these things. So let's go ahead and fix them for all the others. So we need trot, run, dash, and sprint. So for the walk, I'll throw that up on the other screen. So trot should Alright, first things first, we need to have these all come from the Bitey state base. And let's do the same thing for the in error state. Alright, so trot should do this. And then inside of our update and state transition stuff, and our update needs to be changed as well. And it needs to be in the post update. Alright, so let's go do the same thing with the run state. Well, we need to get these correct. This is going to be the trot speed. It should be run speed. Run speed here. Alright, so let's go. Let's actually just copy this whole thing. No, just this. Alright, so we need the run state. Alright, so it's not going to be trot, it's going to be dash. Get dash speed. This is the run state. This is run idle. Alright. We'll just slap this in there. Throw this on top. Over here. Alright, let's double check on that. Running here, trot idle, trot idle, trot idle. Runs here as well. Alright, good. Alright, so the bitey dash state. Let's fix it. And this is kind of copy pasted, but it's the right kind of copy paste. We're only copy pasting the stuff that actually needs to be modified. So this is going to go dash to sprint. Refresh that. Alright, that makes sense. Get that. And we're gonna change this to we need a maximum speed. Can I reorder events? Let's see if we can reorder variable in Blueprint. Oh, just like that. Alright, good. Do you have friends or acquaintances who went through computer science, yet have no interest in actual programming? So what exactly are you saying? Is that you have friends who went through computer science or something similar to it, but are like, programming's stupid? Or are you saying the opposite? Because pretty much everybody who I went through comp sci with, I mean, all we did was program. So, like, it was literally a college for programming. They graduate and get a job that's not in development or like IT. What? Like, I mean, you're gonna get paid less. Like, that's. I mean, is it just settling on like, well, I need a job, or is it I learned how to program. I cannot stand programming. I never want to do this again. Please, for the love of God, just kill me instead of make me do programming. Because if that's the case, well, I mean, a lot of people in a lot of people. I went to DigiPen, which is a private college specifically for game development. Alright, so we need the max speed. And I'd say the dropout rate, like when I was there, it was a college of 500 people, and the graduating class was like 80 people. So like I think we came in with like maybe 200, 300 people for freshman year, and we graduated 80. So, it's a huge drop off in people. So, and a lot of that was due to people were like, okay, I think I want to do game development and stuff like that. Okay, I'm going to have to program, et cetera, et cetera. And they get into programming and they just realize they absolutely hate it. Like, because for you to be an engineer and be a programmer, like, you have to love programming. Otherwise, you're screwed because your entire job is programming. So if you're not absolutely in love with it, you're going to go insane. And I think things like IT and a lot of other jobs, you can hate it and still kind of get over it. But if you're frustrated while programming and you absolutely hate it, it's really difficult to stay motivated to get stuff working because it just takes so much damn work. I don't think money would be enough to motivate me to program I could just say it right now. Money is not enough to motivate me to program stuff. Because like when I was at Amazon, I got put on a project that I didn't want to work on and didn't like the people I was working with at one point, and I was just like, I could not even sit in the chair. Like I physically just got so angry that I could not work. And I had to just go home and then came back and was like, I resign. It's like, and you know what? I am I don't want to do this job anymore. Alright, cool. So we don't have the in-air state stuff going right now, but what I would like to do is... I'd like to add a little bit of flair to this. So like inside of our stationary state, we can actually do some interesting stuff, right? Like, so we go in here, we're going to go into our breathe animation, right? And let's actually register for animation call. Gosh, excuse me. Oh, let's register for animation callbacks. Where do we do that? I think I threw that in the examples. But yeah, programming is one of those things that I think a lot of people, when they kind of get it, they want to get notified. Yeah, okay, here we go. Where you think it's okay, like a lot of people went into game development stuff and were like, I could totally make games. I like to play games. I can make games. And just one of those where, ugh, it's awful if you don't actually like it. Alright, so this initialization for the stationary state should derive from the byte base. State base, yes. Alright. And we should also call our parent. Add call parent. Yeah, it's one of those things people just either love it or hate it. It's probably like fishing and other stuff like that. Like, I really like fishing. And a lot of people would be like, oh yeah, fishing, you know, like, what do you do? Like, just drink the whole time? Be like, no, you just fish. You know, like, what the hell? Like, that's just boring. You're just sitting around doing nothing. You're like, but when you actually catch something, it's really rewarding. And it's also just relaxing. Like, you're out in nature. People just look at you like you're crazy sometimes. Alright, so we want to bind our events on animation end. So I actually want to, this is an interesting use case, where the on enter and on leave actually make a lot of sense to use here. So it's basically like when this state enters, it's going to bind this event, and when it leaves, it's going to unbind the event. So let's see. Unbind on animation end. Ugh, this just looks ugly. Like, I don't like how it has this odd thing going here where, yeah. Ugh, that's just gross looking. I'm a good speaker for being a developer. What? Did I just like freak out and not say anything? Because, yeah, I don't know what the hell I'm doing. Alright, so this is going to be on animation ended. So when this animation ends, I'm gonna roll dice basically, and so let's see, random float returns a random float between 0 and 1. So let's do a comparison. So let's see, float is greater than a certain amount, then we'll branch. Alright, so if the random float is greater than, let's say, 0.1, then we're gonna not do, yeah, we'll do this play with duration and loop over here with just our normal animation. Otherwise, we're going to play some other animations. So we'll roll the dice. And maybe, do we need the multi-gate? Now what was it the if-else? Yeah, the if-else gate. So if it's greater than 0.2. Alright, so if it's greater than 0.2, and then if it's greater than 0.1. And what we're going to do is, if it's greater than 0.2, play this one. If it's greater than 0.1, then I'll play a different animation, and if it's greater than point blah, it'll play another one. If it's between 0 and 0.1, it'll play the third anim. So we can just do it like this, and what 3 animations do we want to play when we're stationary? Let's take a look at Bitey's animations. What 3 animations would be good to play? I think looks like we could do board and look. So we've got board and look. So let's just slot those in there. So let's see if that works at all. Loop, false, false. Loop on breath is true. So let's see if it actually works then. So if we're just standing here, we should, yeah. Okay, so he looks around. All right, when the animation happens, he does that. He gets frozen though on this one. And why is that? So let's see. He's just looking around. That's really funny. He's just looking around and he's so like, alright, this is cool, and then he just gets all pissed off. So what was this value? It was 0.5 and we're ending up here? Alright, why is that? So if the first condition is true, then we go to 1. So the first condition was false. So if 0.2 is greater than... Oh, okay, I've got my conditions messed up. These are supposed to be opposite. This should be 0.2, and this should be 0.1. It's like, why is it all weird? So he should have an 80% chance of replaying the animation, and then he should have a 10% chance at each one of the others. That's pretty baller. I'm liking that. He's just so pissed off. He's like, God, I hate my life. We're just sitting around. Alright, so we need to get the air stuff working properly. But that's the cool thing, is now that all this stuff's out on blueprints, we can actually do little things like make them look around and all that, which is pretty awesome. So I'm going to need to take a very short break here, just a couple minutes, and I will be back. Let's see, we're 4 hours into this thing. So yeah, I'll be back in just a minute.